Hey everyone, I'm Courtney Turner. Welcome to today's live stream. We are going to be talking about the DLM5000HD. I guess we can give some people a little bit of time to join, but while we wait, I can just talk a little bit about what we're going to be going over today. So we'll be showing off our new DLM5000HD. The biggest thing about this oscilloscope specifically, it is 12-bit. It's a 12-bit oscilloscope, so that's one of the major upgrades that was made here. It is an 8-channel oscilloscope with tons of features, tons of analysis and measurement options. A lot you can do with this pretty compact 8-channel oscilloscope. So, like I said, maybe we'll give it a couple seconds. Do we have anyone in right now? All right, so cool. Well, in that case, let's just go ahead and jump right in. So, get all zoomed in on it. So, like I said, this is the DLM5000HD 12-bit oscilloscope. Right now, I just have a demo board set up with some signals that we'll show off on it. So, first we'll just start off by showing off some of our serial bus features. So a really cool thing about this, I just have this is a serial bus waveform. We're not doing any type of analysis on it right now, but we can go into the serial bus menu, turn that display on. Now you can kind of see some things happening already, but let's say I didn't know anything about this signal, but I still wanted to be able to get these IDs. One really cool thing about the oscilloscope is you can go into this setup menu, and if you know all the things about your serial bus signal, you can just set them. But if you don't, you can do this auto setup feature, which just takes a couple seconds. And then you can see I'm starting to get some IDs here. On the top, this is our signal at our time per division. The bottom, we just have a zoomed in waveform, but we can adjust this time per division to where we get more packets of data or less and get really fine detail there. But if we wanted to get several packets on there and then zoom in, we get kind of the best of both worlds. We get all of our packets coming through, but we also get to zoom in and see specifically some IDs right here. You can also see a list view on here. And so you can see I have a list of all of my IDs coming through, their timestamps, the data. So all of that is listed out as it's running, and you can also, if I stop it, we can also scroll through and see everything. So for our serial bus, this is a CAN signal, but for the DLM5000HD, we have CAN, FlexRay, CAN-FD, LIN, CXPI, SINT, PSI5, which is airbag, UART, I2C, SPI, and you can even do a user-defined serial bus. Now, one other cool thing that was added to this model specifically was the ability to do a serial bus auto setup on an already acquired waveform. So let's say that we turn serial bus off. So we're just back to just having almost like a normal waveform. This is our serial bus data. If I stop this, I can then go in to the file menu. I will save this file, save a waveform. All right. So say this is a saved waveform, I walk away, I come back a few days later, oh, I forgot to do my serial bus analysis. For this waveform, what do I do? So we can go in and we can load that waveform that I just saved. So again, save waveform. And now if we go into the serial bus menu, if I go back in here into the setup, and turn it on, I go into the setup here. If I click and hold the auto setup button, you can see here, I can select current waveform, so I'm going to keep the run stopped, set the current waveform and hit execute. And then we have all that same data that we had when we were running it. So this is just really cool if you want to come back to a waveform that you didn't perform serial bus analysis on and do that. So let's see. That's, you can also search through your different IDs. If you had a specific ID you wanted to search on here, you can do that in serial bus. But there's a lot of features in here. The coolest one to me is the auto setup feature and just all the types of serial bus that you can do. So like I said, I have a demo board, so let's change over and let's do a different signal. So we'll go ahead and just set this back to default settings. So I'm going to change this. And I'm actually going to add a probe as well, so we'll have 2 channels. All right, and then I'm just going to do an auto setup. So what I have here is a voltage and current waveform. Of course, again, it's a demo, so this is kind of representative of a voltage and current that we have here. And I want to do switching loss analysis on this, which is something you can do with the DLM5000HD. So if I go into the analysis menu, go to power analysis, there's a few different types of power analysis you can do. You can do switching loss, like I said, SOA, harmonic analysis, and then the I²T. So we're going to do switching loss analysis. So in here we can set up our probe for our voltage and our current. And then if we go into measure setup, there's different types of calculations you can set up, items that you can set up, which will change, and then changing all your reference levels so you get exactly the data that you want to see. I'm actually going to turn here, this is doing a math, so now you can see this red is the power that's calculated from the voltage and the current. So you can see how it overlaps, and you can see the power being calculated. If you wanted to, you can go into the display and we can separate those all out so you can see just your voltage, just your current, and just your power waveform. But I think for this example, it's just easier if you look at it overlapped. So I'm going to change it back to single. Then we'll go back into our analysis menu for the switching loss. So you can kind of see we have these indicators here. So it's kind of bottomed out. It's not actually touching the voltage and current. So let me move my reference levels, which you can do by clicking and dragging or by actually setting the values in this level setup menu. And it kind of goes through and shows you exactly what you're doing. But now you can see I have these indicators on showing me exactly where it's getting my calculated data from. And then down at the bottom you can see all the measurement items. So the turn on power, the turn off power, the total power, watt hours, all that information that you need for switching loss, and the cycle count that it's calculating from. All of that information is on here. So it's just a really cool feature of the oscilloscope, and something that, you know, this DLM5000HD does really well. But as cool as this stuff is, let's take this from a demo board and let's go measure some real signals. So one great thing about the DLM5000HD is, like I said earlier, it's pretty compact, you know? It's actually really easy to carry. So we're just going to take this back to our test and measurement lab. I hope everyone enjoys the Christmas decorations. How do we feel about decorating for Christmas before Thanksgiving? We had some difference of opinion in the office here. Some of us said that for sure, yeah, let's go ahead and put Christmas decorations up. Other people were like, what are you doing? And you can kind of see the office is split 50-50 almost. All right, so we made it to the lab. I'm just gonna set up really quick. So another great thing about the DLM5000HD and all of our oscilloscopes is this starts up really quickly. So you'll see how just fast and easy it is. If you need to take it from one place to another, I mean, that was what, maybe less than 10 seconds for sure. So I still have all my setup that I had from before. So I'm just gonna go ahead and do a default of that. So now we're already up and running and ready to start measuring some new signals. So like I said, before we were using the demo board, but now we actually have a motor dyno that we're gonna connect up to. And it has 3 phases of voltage and current coming off of it that we want to measure with our oscilloscope. So go ahead and turn that on. Get the probes down. Sorry about that. All right, so now you can see our motor starting to spin. So let's connect up to it and start getting some signals. So I have 3 differential probes and then 3 current probes that I'm going to be using to connect. So we have our first diff probe. And then, so that's for our first voltage. Now I'll connect up my first current probe into channel 2. We'll do my second voltage. And, oh, actually this is my third voltage. Sorry. My second voltage. And my second current. And then my third current. So we'll just go ahead and start with an auto setup, see what we got going on here. And let's go ahead and separate these out. So now we have 6 displays. So like I said, voltage 1, current 1, voltage 2, current 2, voltage 3, current 3. Now we can go into each of our channels and just set those up. So for my first voltage, yeah, good. So they're already set. So this is a 50-to-1 voltage differential probe. Now for my currents, it has the probe set as 1-to-1, so it's reading it as a voltage. But if we go in here and select current probe, we need to set this up as 10 amps to 1 volt. And then we'll just follow that for the rest of the channels. For my third voltage, we need to set 50-to-1. For my 4, so my current, set this to current, 10 amps to 1 volt. And then my final voltage is set right, and my final current again, 10 amps to 1 volt. So now everything is reading properly. We've got all of our scaling done correctly. And you can see as it's moving, as the motor's spinning, you can see the voltages and currents on there. So, I mean, of course, this is really cool. This is great for if you want to, you know, if you're trying to catch some kind of transient event that's happening on your motor, you can set up triggers to do that on here. If you just need that really fast waveform data, you can capture that on here. But the oscilloscope also has a power measurement mode. So if I go into this analysis menu and select power measurement, we can turn that on, and it automatically recognizes your channels on here. So reference channel 1 and 2. So we have that on. Go into the measure setup. Again, we can change all these reference levels if we need to, but we can go in and turn on our items as well. So you have a variety of power measurement items. So U peak, URMS, we'll select that one. The voltage AC and mean, we'll do average frequency on there as well. And of course we'll add our power. And then we can also do all those same things but for current. So we'll select our IRMS current. So now you can see those showing up at the bottom here, but we have 3, so we can actually go in here and we can set up to 4. So that's 4 voltage and current pairs that you can calculate power on. So if I turn the second one on, go into my measure setup, I can do all the same things. So voltage, frequency, power, current, and again, all of those are on here. And then if we go and set up our third one, turn that on. Again, we'll select voltage, current, frequency, power. So now for all 3 of these voltage and currents for this 3-phase power, we can calculate all of the normal power measurements that we would need to. So all of those get calculated on here. You can read each one of them, measure them. Like I said, you can do triggers on here. If we go into our trigger menu, so if we go into here, we have a variety of different enhanced triggers. Of course, you have the simple edge trigger, but there's also an edge OR, and that takes, if for example, you had problems maybe on multiple of these channels, you could set up an edge OR trigger, which would, it would trigger if any of the channels met the measurement conditions that you set. There's a pattern trigger, pulse width, rise and fall time, runt trigger, timeout, window. The window is really cool if you have a sine wave, and it will track that, right? Or the window is cool if, sorry, I'm getting my triggers confused, but this one is really good if you can kind of, hopefully you can see it here on the camera, but it sets up this window, and if your signal goes into that or outside of that, it will trigger. But there's also window OR, so you could set those levels for each channel, and then if any of those channels goes outside of that specific window, it'll trigger. Then an interval trigger. Now going back to the serial bus we were talking about earlier, you can set any of those serial bus as triggers as well. So a lot of trigger options there. Like I said, this oscilloscope is really powerful, and especially at the 12-bit resolution, I mean, you can get really fine data through this oscilloscope. So, and for any kind of motor testing you need to do, any kind of 3-phase testing, you're going to need more than just a regular 4-channel oscilloscope. You'll need those additional channels. And we could also use these 2 channels for CAN if we wanted to, for serial bus. You know, any of that stuff can also be input here if you wanted to see that data simultaneously. And then there's also, we have the 4 logic inputs as well. So I've done a lot of talking. Do we have any questions come through? Okay, I guess no questions yet, but yeah, I mean, we can maybe stay on a little bit longer, see if any other questions come through. Anything about the motor, the oscilloscope. One other really cool thing, I don't know if you can see it, but we have a power analyzer over here that you can actually synchronize the power analyzer and the oscilloscope through IEEE 1588. So what the power analyzer is really good at doing is getting super accurate voltage and current and power data. What the oscilloscope's really good at doing is getting this really fast waveform data. So you can actually time synchronize these, bring them into our software, and see all the data that you need and get that accuracy and the raw waveform data at the same time. So, any other questions? Well, if we don't have any questions, we can end it here. Of course, this has a lot more features to show off too, but those are just some of the things we wanted to focus on today. If there are any questions later, or if there's something else you want me to show, we can always hop back on, or just create a new video. So yeah, like I said, that's pretty much all I had to show today. Thank you for everyone who's joined. If you have any questions after the fact, you can always go to our website at tmi.yokogawa.com. There's a contact us page on there that you can go to get to us. You can also reach out to our support email, which is yca-support@yokogawa.com. So any questions you have, please feel free to let us know, and thank you for joining.